This one here from yesterday was the 6 points. So we're looking for 1, 2, 3, 4, 5, 6, and then the asymptotes. So the asymptotes work like a point. If y equals 0, I put it into y, nothing changed, so it stays the same. We'll do another one of these as well, right? And I'll do my chart a bit longer so you can see that. X equals 0, 2 times 0 keeps it the same, right? So nothing changed. So you're always showing the asymptotes with the dashed line and the equation, right, to show me what that is. All right, so we've got that, and let's try it again. So for this case again, if it's in the bracket, in this case the bracket is not a bracket, it's the absolute value, right? So in the absolute value. For this one, in the bracket was meant with the x on the bottom, so if it's in the denominator, and this one, it was in the square root. In the square root means it's horizontal. Okay, outside the square root means it's vertical. So here, in the bracket, in the absolute value means it's horizontal. So that would be a horizontal reflection by negative. So again, I'm going to do my chart. Okay, my y has not changed, so my y will remain y. But for my x, it's going to be negative because it's a reflection. And instead of times 3, it's 1/3 x, like that. Okay, so whatever it is, it'll be negative 1/3 x. Then we have our points. So again, you can do a separate chart. I like to just list the points here. So for the absolute value, for the parent function, we know that the parent function is this. Right, so the parent function is the absolute value. You can recognize that, I hope. We know for the parent function, if we're taking this, then we've just got dot at the 0, 0, 1, 1, 2, 2, 3, 3, and it keeps going up like this, right? -1, and it goes up with 2 lines. Okay, in this case, it asks you in the question to graph the parent function. That's why I'm graphing it. If it doesn't ask you to, then you don't have to. Okay, but this case, it was asking you to graph the parent function to show that. Okay, and then now you're taking all the values. Now, the values here, there are so many, right? There are so many I can choose. 1, 1, 2, 2, 3, 3, 4, 4. You can choose an infinite number of points. I don't want to choose an infinite number. Technically here, I only need 2 points, right, to get that side straight, and then kind of 1 point over here so I can get that side straight. Now, choose your points.
The grade 11 classes with letters of H, I, J, K, down to the editorial statement. Thank you.
Choose your points strategically, right? So I don't want to put in 1, because 1 times 1/3 is going to get me a third back. It's kind of a mini point little bit. 2 even isn't that great. 2 times 1/3 gets me 2/3. Wouldn't 3 be nice? 3 times, so choose 3, 6, like choose it strategically when you can. Right? This one has so many points you can choose. So I'm going to choose definitely 0, 0, right, to get that point. That's a good one. Then instead of choosing 1, 1, I'm going to go, well, 3, 3 is a lovely one, because then times 3, 1/3, it'll get me a nice number. You could have chosen 6. So 6, 6 would be good too. But if you can, like in this case, choose something that's nicer to plot. Right? So for this nice linear, you got so many points to choose from. And then on the other side, I'll do -3, 3. Right, so it's -3, 3, or -6, 6. So choose something that's a little bit nicer to calculate when you can. So when I put this number in, 0 goes in for the x, so I get 0. 0 for the y, 0. 3 times -1/3. So again, you don't have to show me the calculation. If you want, some people show it to me, and some people go, but I can do that on my calculator in my head. That's okay. You're going to get -1 back. Right, -1/3 times 3, and then that's just 3. -3 goes in. I get +1 back, and then a 3. So you can see when I plot this lovely thing, I still get 0, 0, right? 0, 0 is there. -1, 3, which goes here, and 1, 3. And then look, can you follow the pattern? Right? So if it's up 3, you can actually continue the pattern a little and go, look, I know that the slope is the same, so if you want to, you can make it even better and just continue the pattern. What do I mean by pattern? The rise and the run, because they're both lines, right? So if I know it's going to be 3, then I know it'll keep going up by 3s. So you can draw even more, but at least, remember yesterday we were talking about, I want 3 points. Okay, so 3, I would want this one, and this one. And like I said, if you can do a little bit more, you can, because you know the step pattern, right? The rise and the run. right? But 3 points. I would want the vertex thing and then those 2 points. Okay? Any questions with that? Yeah.
Do we need to label something?
You don't have to label it. I'll look for it. Usually we don't ask for parent and the other one, so there'll only be one graph. Yeah. If you want to, you can label that one y equals absolute value x and that one there, but I'm not going to make you. Yeah. Okay. And typically we don't ask for parent on top of the other one because for some students it's too distracting because you got too many. So if you want to, you can, but you don't have to. Yeah. Okay. Yeah. Typically we're just like if you have too many points, sometimes it distracts you. Is that all right? Okay, we're going to try another one. Flip over. Oh, sorry, backwards question. I'm giving you the graph, and then we're going to get the equation, right? So if you can go backwards and forwards, that means you kind of get the concept a little bit better. So here, I'm giving you the graph, so we know which type of graph is this one. Yeah, absolute value. So hopefully we recognize, right? This one, we know it's, right? So we know the parent function. You go, okay, I got that. This one? Which one? Square root, yes. Right? And then this one, parabola, right? Quadratic. Right? So we're recognizing it. Yes, wonderful, right? So look at that. We've got that memorized from 1.3. We know the form, the graphs. Beautiful, beautiful. So then here, determine the equations of the transform function. So we know that. And if I give you a grid like this, feel free to draw on it. Count the squares, draw on it. You don't have to keep it pristine, right? So I'm going to draw. I kind of like to draw the original on this. This is where I kind of find it a little bit more useful, where I go, okay, so I know the original. You don't have to draw the whole thing. I know the original is 1, 1, 2, 2, right? So I know it's 3, 3. So you kind of go, okay, so I know it would be here. You don't have to draw the whole thing, but if you're like, you know what, I kind of want to get the idea, you can. Draw as much as you want on it. You can sketch on top of the grid, so don't be worried about drawing on the graph I give you, if it helps. Okay, so I look at that and I go, okay, so I know that the point should have been over 1, up 1, right? Over 1, up 1. But horizontally, instead, I went over 2, up 1. Does that make sense? Right, so look at, I would normally go over 1, up 1, but I went over 2, up 1, because there's my point. So then horizontally, and again, we're only looking horizontal now, right? So the question was asked about the vertical thing. Yeah, you can look at things vertically and horizontally. Today we're looking at it horizontally. And then for 1.8, I'll say it's your choice. You can look at it horizontally or vertically. We'll talk about that. Okay, sometimes there's choices, of course. Not sometimes, but horizontal and vertical are related. But we're looking horizontally today. So we're saying it's twice as wide. Does that make sense? Right, so it's double. So instead of over 1, up 1, I went over 2, up 1. You can say, okay, I went 2, and look, it's at 4. So you can check another point if you want, but really the 1 point is enough. Right, so it's double as wide, right, twice as wide. So then when you write your equation, you're going to go y equals, anything else happening with that? Nothing. Is it reflected horizontally, left and right? No, it looks the same. It could be, but it makes no difference visually, so I'm not going to say there's a reflection. So nothing else hasn't been shifted. We're going to do that for 1.8. We're going to add shifts to it. So I'm going to take that and move it over. So you're going to be like, oh, and it was also shifted. In this case, nothing. So you take that and you say, well, in the bracket, right, in the bracket, which in this case is absolute value. Absolute value is the bracket, right? So that's the special bracket. It's twice as wide. So if it's twice as wide, don't put...
down to the auditorium.
Don't put 2 there, right? Remember, everything's reciprocal, so it's going to be 1/2. Don't put 2. I know it's twice as wide, so here I know it's going to be horizontally times 2. In my brain, I'm going horizontally times 2, but instead of writing the 2 there, I write 1/2 x, right? So it's reciprocal. Is that okay? Right, so it's twice as wide. Try it again. I didn't draw the dashed line. Normally I would have drawn that, but again, we did this on a computer, and the computer puts it right on top of the asymptote, which means axis, so you can't see it. So normally I would have a little hand-drawn asymptote there just to emphasize it, and I shouldn't do that. Okay, sorry. We did it on a computer because we thought it'd be good, but then we can't see asymptotes, right? it draws it right on. So I would normally just do that so you could see there's an asymptote. I'll try to fix that next time. Right, on a test, I'll make sure that I kind of hand draw it. Now, here, we know that it should be in these two quadrants, right? So if you say, okay, well, I want to draw the original just so I have an idea, you go, wait, but my original should be here, right? Over 1, and then half, and then 2. Remember, those are the 3 points I want. So you don't have to draw the whole thing. Just go, but I'm in the wrong quadrant, which means that instead of being here, it was flipped over, right? Instead of being here, it's flipped over. So it's a horizontal reflection. So right away, I know I'm going to have to put a negative there because it's a horizontal reflection. Okay, so then here on my equation, 1 over, okay, try to put the equals here in the middle, like that, not too far up, not too far below, so middle-ish, right? 1 over. And for this one, remember how the absolute acts like the bracket? This absolute acts like the bracket. For here, the denominator is the bracket. That's where all the x stuff goes. So anything horizontal goes in the denominator. Yes?
What else counts as a bracket? So the absolute, a bracket, a fraction.
We're going to do them right here, right? We're doing them all, I keep doing them all the same 4 over and over again. Yeah. Right? So then that's the absolute, that's your bracket. The denominator here is your, instead of a bracket, it's in the denominator. Okay? So here, we've got that. Okay, then we're going to put in that it's horizontally reflected. So you're going to put a negative here on the bottom. Now, if you were to look at the graph here, what if I did a vertical reflection? So guess what? Are they the same? So if I vertically reflected my original graph down and then up, it'd be the same. That's why when we taught you fractions way back in grade 9, we kept saying move the negative up. Because a horizontal, the negative, actually means the same thing if it's a vertical or in the middle. So that negative could technically be in the middle or the top or the bottom. It's just you can only put one negative, okay, because it's one reflection, right, not two. Don't put it on the top and the bottom because then they cancel out. So the negative here, we're talking about horizontal, so I'll put it in the bottom, but you could have actually said it was a vertical reflection. So this is my original graph. So I'm going to show you the original graph is here in red. Okay, so the original graph is like that. I'm reflecting it horizontally, which means these guys flip left and right. So, right? But if I reflected it vertically, it would also be the same thing. So that's why this negative could technically be on the top, middle, or bottom. Okay, they're all the same. Right? So vertical, horizontal reflection are the same. So I'm going to put the negative. Now, has the shape been changed? So it should be over 1, up 1 to get to the first dot. Right, over 1 up dot, or this one of these dots, one of the points. So, sorry, so should be over 1 up 1 like that, right? What happened on this side? Is it over 1 up 1? So it should be over here from the center, up 1 here. It's not. Instead of over 1 up 1, it's over 2 up 1. You see it's right there? So again, it's twice as wide. You want me, I'll just zoom in for a second, right? So it's twice as wide. So instead of over 1 up 1 there, it's over 2 up 1. So you can see it's there. We're not going to tend to give you anything too strange, like it's not going to be a 7th or something, right? Where you're like, well, I don't know, I can't tell where the 5. So the point is actually on that exactly where 2 is, right? So -2, 1. So that point is there. So it should be pretty clear. So you go, okay. So then that means it's twice as wide, same as this one, right? So if it's twice as wide, we don't put the 2 there, we put 1/2. So put the negative, and it's 1/2 x. Right, so this negative can go in the middle or the numerator. Okay, they mean the same thing, middle, numerator, or denominator. Yeah.
Do you put in negative a half at the bottom because it's the reciprocal of 2 being 2? Like
the 1/2, it's because, yeah, you always do the reciprocal. So it's exactly what we did here.
so
Right?
because
It's always the reciprocal.
It's 2 up 1. And it's,
Horizontally 2.
It's like because it's horizontally 2. Then
Yes.
Then you gotta flip it.
Yes.
Rise over.
Yeah.
Okay.
Not rise over run. We're not doing a line.
No.
No. No rise over run. Okay?
Like, do
You have the question too? Your hand is up. It's okay? Okay. So here, this is because it's horizontally stretched by 2. Horizontal stretch by 2, so yes, so flip. Okay, so it's going to be reciprocal always. And the negative, right, is because it's on the other side. So that's all we're working on in 1-7, right? And we're going to combine it today. Yep.
Do you mean it's moved all the way 2 to the left from the y-axis?
It's not moved, it's times 2. It's twice as wide from the y-axis. Yeah, horizontally. So when you're saying that you're stretching your shirt horizontally, wouldn't you stretch it this way?
Yeah.
Right? Versus this way. So I stretched it
If it was
horizontally.
stretched up, would it be -2?
We're going to talk about that later. So you're asking hypothetical, so just let's focus on the horizontal for a minute. Okay, so just focus on this, right? And you're asking what if, so those are going to be done here, and then we're going to do the vertical in a minute. Okay, so they're the good questions, it's just that you keep asking, so I'm going to have to flip to another page and explain another concept, which we're going to get to. So good questions, but just look at the horizontal. Focus on what we're doing here. Okay, good questions, but just wait, pause, okay? Right, because you're overthinking it, because then you're like, what if, what if? So just look at this. Yeah, but no, but we're only looking at horizontal, because you're saying, what's the vertical pattern? So just wait, okay? We'll get to that in a minute, so just get this pattern, don't overthink it and go into the next one yet, okay? So hang on. Okay, so good, but just pause. Okay, so look, horizontally, we're backwards, right? So reciprocal. Good? All right? Okay, so then try it again. So we're doing the types, right? So now the absolute acts like the bracket. So in that bracket, which is absolute. For the reciprocal, underneath is like the bracket, right? Where we had the quadratic, it was in the bracket, but for the reciprocal, it's underneath. So underneath is horizontal. We good? Right, so underneath. For this one, it's in the square root. So in the square root acts like the bracket for this one, right? So in the square root acts like the bracket. So that's the horizontal part is in the square root. So here, again, we're going to take a look at it. So we know that the original should be over 1 up 1, right? Over 1 up 1, right? And we're starting with all these, which is very nice because they all have over 1 up 1s. You'll notice that seems to be a pattern for all of them, right? Because they're starting with some nice